Hello guys, welcome to IIM Messi, Empowering People, Enhancing Education. Let me introduce myself guys. Um, myself, Shiva Prasad. I am an AWS Certified Solution Architect professional. As a part of my job, I interact with clients and I help them in migrating the environment from the on-premise data center to AWS and planning the DI solutions in AWS. I have done a couple of migration from on-premise to AWS environment, and we have designed the infrastructure for startup organizations to host their applications in AWS. And apart from this, I also have a knowledge on virtualization platforms such as VMware and private cloud platforms such as OpenStack, along with my AWS knowledge. So guys, today we are here to know about the cloud, something about the cloud. The high level understanding of cloud is what I'm going to give you as a part of this session now. So when you think a cloud, everyone has their own perceptions. People think it is a cloud, it is something like a virtual thing. Guys, remember there is no such concept called a virtual thing. So physically that has to be somewhere. So now let me give an example so that you actually understand what is a cloud. And on a daily basis, you might be using the cloud on a day-to-day basis, but you might not know that it is a cloud. So let us talk something about the cloud. So here I have given you a iCloud, a Dropbox. So guys, we use this iCloud and Dropboxes on a day-to-day basis. So what we do is that we have our mobile phones, we take a pictures of it, and we have lot many pictures. So the moment we are having lot many pictures, what happens is that our phones will be out of memory. So once it is out of memory, whatever the only idea we get is that dump our pics into some location in a very secure location so that you will be able to access it in the later time. So in that cases, if I am using an iPhone, I would prefer to put it in my iCloud. I am using an Android phone, then I prefer to put it in my Dropbox. So now what are these Dropboxes and iCloud doing it? So how are they going to store it on a cloud? Just like that. So what is happening in the backend is that though they are a Dropbox, it is just an interface to you, a web interface for you to put all your data. But in the backend, there is a lot of mechanism that is going to happen. So let me tell you that how the traditional way of things happen, and then we'll talk about this Dropbox thing. So where do we store our data now? So in order to store our data, we need to have a memory. So in our phones, we use small SSDs drives with 16 GB capacity or 64 GB capacity. No. But how the organizations are going to manage it, they are not going to use such memory here. They are going to store this in a storage environment. Now what is a storage and where is we getting the storage? The storage you are getting it from a storage server. So now what is a storage server? So storage server is nothing but again a physical server which has a lot many hard disks in it, and they are going to pull it off, and on that pool they are going to give it to your cloud environment. That means when you are storing your data into a cloud environment, any picture that you are putting in, it is physically being stored on a physical server. But do you think organizations are going to put one or two servers in their organizations? No. So they are going to build thousands and thousands of such servers, and together combined that we call it as a data center. So now, one more term called a data center. Now let's talk something about a data center. Now what is a data center? So data center is nothing but a physical location where we put all our data. So in order to put all our data centers has to manage the physical servers in it. So now guys, when I'm talking about physical server, it's not one or two servers, it will be lakhs of servers. One data center can consisting of some 80,000 to 1 lakh of servers, and the size of a data center will be combination of multiple football stadiums. That is the size of data center that organizations are building as of now. So now, sitting somewhere remotely, I am logging into my Apple Cloud to put my data in it, and physically they are managing it on my physical data center. So physically locating somewhere over internet, I am putting my data on Google's cloud by using their Dropboxes. So that's how the cloud is going to work. I mean, they are physically managing all this data somewhere in a remote location called a data center, and we are able to access and we are able to put our data into the data center just over the internet. And remember guys, without internet you will not be able to access this. I can say this is a cloud. So accessing some service remotely over a internet is nothing but a cloud. So now let's talk some more depth of this. So now the cloud, you are sitting somewhere and over internet. So now it's not that you will be able to access it only from your home. You will be able to access this from anywhere in the world where you have an internet connection. So with this, what is happening guys, you are getting a high availability of your infrastructure. So you have the freedom of accessing your data from anywhere in the world without having to think of that you're not be able to access the data. Now, so when I say the cloud, it is nothing but a physical data center which is sitting somewhere. So you are logically connecting to a data center, like I told you, you can see here. A data center is consisting of hundreds and thousands of physical servers combined together to give us a huge capacity of servers, huge capacity of storage and requirement. So like iCloud manages their own cloud, Dropboxes manages their own, that is Google Drive manages their own cloud, as well as Amazon is also managing their own cloud in order to give services to the end users. So now let's talk something about services. So Dropboxes and cloud services are giving us storage as a service. Now let's look from the perspective of an organizations who want to host their web servers, who want to host their application servers, who want to host their DB servers, database servers. So now, in order to run a web application or an Apache Tomcat application or a database server, storage itself is not sufficient. To me, I require some physical infrastructure such as a RAM, CPU, network, and disk. So remotely we are able to access some storage remotely, but why can't we get these resources from someone? Because if you're looking in the infrastructure perspective, these components are going to cost huge. So let's talk from a startup organization. So as a startup now, if they want to run their own web server, own blog or own application, own database, they have to buy a physical server and they have to build a small data center for hosting their applications. Okay. So now to get this servers, first they have to invest. Say, let's take an example of some $50,000 they have to invest in order to buy the infrastructure. They have invested in money. So now after investing, what happens guys? They have to manage them. That is management of your physical servers. And then you have to hire an expertise guy who can actually configure your servers as per your requirement. Everything is fine, you have set up your requirement and all, but now why will I have to invest from 50,000 of money in buying the infrastructure? So that's a challenge here. So because since I'm a startup, I don't have that much of expenditure or income in order to invest just on my physical hardware. Just like the way I'm relying on iCloud and Dropboxes now, I will be relying on an Amazon to give me all these resources what I'm talking about. That is RAM, CPU, network, and disk. And since I'm using Dropbox and since I'm using iCloud, I'm paying a monthly subscription charges of some say $10 or $20. In the same way, I will be paying to Amazon for the resources that I'm being using, such as RAM, CPU, network, and disk. As per my usage, I'm going to pay them the monthly rental. That's it. So that's how Amazon is giving us a services called IaaS. That is infrastructure as a service. So Amazon Web Service is a cloud service provider, also known as infrastructure as a service. So when you're talking about infrastructure, it is nothing but RAM, compute and storage capacity, CPU, network, and disk. Okay. Now, why do you think that Amazon is giving you these resources, and what is the advantages for us of going to Amazon for getting these resources? What are the advantages, and why do you think I have to rely on AWS to get this data? So let's look into it. So Amazon is not only giving us the compute and all, they are also giving us compute power, they give us the databases, they also allow us to analyze our data through analytical applications. We have a specially designed developer tools. We also have, you have the ability to create your own network. You have a storage as a service concept. They also inbuilt security mechanisms. It's not that only the infrastructure, they are giving us a complete data center kind of environment without having to invest upfront money in our in order to host our applications. You can directly straight away log into Amazon, create your account, and you can start building your infrastructure without having to think of any data center management cost. So that's how Amazon is bringing up this cloud services to each and every individual in this globe. And now, why do individuals and companies use AWS? So what are the benefits? How is the cloud different from what has been used in the past? So guys, now what do you think? Why do individuals and companies are using cloud? Every individual company is using cloud to save the cost, to overcome the management burden, to get rid of the infrastructure cost. No one wants to invest now in the infrastructure, because when I'm talking about infrastructure, guys, it is very huge. Organizations invest thousands and lakhs of $1 million in just procuring the physical hardware. And moreover, what happens is that every hardware has a lifespan of 5 years. So when I say lifespan of 5 years, that means the servers are given a guarantee or warranty of 5 years. If anything happens to the servers within 5 years, the OEM, original equipment manufacturers, are responsible in replacing the server hardware. They are physical components and they might get paid. So after 5 years, these servers might not be used in your production environment. Again, they have to procure a new servers every 5 years. So recycle has to happen. And the investment and money is going beyond these things, usage and all. But to overcome that, people are now relying on cloud platforms just to save cost, overcome the operational burdens, and to cut down the cost of your infrastructure. Oh, I have one more question here. How do you think organizations are going to save cost on a physical infrastructure when they are completely relying on this infrastructure now? Because it is all taken care of your AWS. Now, the traditional way of doing is that we have to buy our own infrastructure. But when I'm talking about AWS, AWS manages all the infrastructure in the back end. We as a client or we as a customer sitting somewhere in our office premise, we are going to host all our servers such as web servers and database servers and application servers in Amazon physical resources. We are only responsible of running our applications now. We are not responsible of our physical infrastructure management, because the physical infrastructure management is all taken care by AWS. That's the reason for any service that we are running in AWS, we are paying AWS for the resources that we are using. And within the amount of money that we are paying, they are managing or they are overcoming all these challenges. That's the reason people are going to clouds and all. And benefits, the benefits are you're cutting down the cost of your infrastructure, you're cutting down the cost of your management, you're cutting down the cost of your expenditures on monthly expenditures on maintaining your infrastructure. And how is cloud different from what has been used in the past? So guys, to this we have to think of four things. One is a high availability, fault tolerance, and scalability and elasticity. So guys, these four things, these four terminology will actually make you understand what is that a cloud has brought a change in the traditional IT and how this is different from our past infrastructure things. So let's look into it. So looking the advantages of using the cloud in terms of personal things. So that is, here I'm going to talk about a high availability and fault tolerance. So guys, you have a mobile phone. Let's take you have a mobile phone and you don't have any cloud backups now. You don't have any cloud backups. You are having around some say 1 GB of pics in your mobile phone. Say it is stored in one of your memory disk, SSD disk. So due to some reasons, your SSD disk has failed. So guys, now what is our situation now? So our SSD disk has failed. We had no backups, and
We lose
how
all
will
data.
you? Yes, our data will be lost. So how can you overcome this? So everyone will say that I will put my pics in our Dropbox or AWS or some cloud environment. Now in this case, even if your memory disk is down, you still will be able to access your pics from your cloud environment. But now your mobile phone is thefted. Someone has thefted your mobile phone, but your pics are still available in cloud. Now how will you access them? You have your own desktop, you can access it from your desktop. You have your own personal computer, you use it from that means irrespective of the device, you will still be able to access the data from anywhere in the world. That is what a high availability is. That means irrespective of failures, even if your mobile device is failed or your computer device is failed, your work computer has failed, you will still be able to access the data from anywhere in the world by using any of the device. This is what a high availability is. That means irrespective of failures, you should still be able to access the data. Now let me compare this with a enterprise perspective. I am having one physical server. I have a web application in it, or my website is hosted in my physical server. So guys, due to some power fluctuation, so for in order to run this database, we need to have a power, we need to have power, we need to have all the network and everything. But due to some reasons, my network is down. Due to some reasons, my power supply is down. So in this case, what happens to my web service? A guy sitting somewhere in US and now he's accessing my website. It is like an Amazon.com and e-retail website. Now, due to these reasons, the site will be down and clients will not be able to access this thing. So how can I overcome such situations? I can be able to overcome the situation by putting one more server, configuring in such a way that if one server goes down, I will still be able to access my application on the other server. So, looking in terms of cost, if you are investing some $20,000 in buying one physical server, you have to additionally put the same amount of cost in buying your physical infrastructure to overcome the physical failures. So now your cost is going to be doubled looking in terms of a highly available infrastructure. If I am going to a cloud, I don't have to invest this money in my cloud infrastructure. I will be able to do it, and I'm just cloud is going to give me this highly available infrastructure. And fault tolerance. So during this transaction, that means a server has failed and I'm migrating my application to the other node, or I'm making my secondary node available. This might take some time, such as 5 minutes or 10 minutes. But I'm running a business critical application that it cannot even afford a 5 to 10 minutes of downtime. So I should be able to configure this application in the fault tolerance. Fault tolerance means a zero downtime. So I will be able to achieve this kind of infrastructure, this kind of highly available and fault tolerance environment with the help of a cloud services. And now looking in terms of a common enterprises. See here guys in the picture. So in 2016, my organization has some 10,000 users. So to accommodate these 1,000 users or 1,000 applications, I have bought 3 servers in my data center. Well and good, my business is running excellent. So during this growth, I have estimated that by 2017, I will be getting some 5,000 users. My guess didn't go wrong, and to accommodate this, I have procured additional 3 servers. But in 2018 now, I thought my business infrastructure is going to be some 20,000. I have estimated this in such a way. So, if this is on-premise guys, I am talking about an on-premise infrastructure. So in that case, what organization will do? Organization is going to procure the servers which are needed to accommodate some 20,000 users, and they brought all the servers. And organization is very much happy that their infrastructure is growing, the client base is growing, the users are growing. But what happened is their expectations didn't meet up. So instead of, they have expected 20,000 users, but their users have grown only to 7,000. So in this case, what happened to organizations? Now organizations are pretty fine. They will be able to accommodate 7,000 users only in 6 servers, but they have procured some additional servers which are of no use now. So what has happened to organizations? So they won't get these servers for free of cost. They might have invested money now. Now this investment has gone in vain. People are now, organization has nothing to do with these servers, but they brought the servers and they will not be able to use these servers in their organizations. So that's the reason people are going to clouds. That means they have a scalability here. Now the organization on-premise thing, you have the ability to scale out your infrastructure. Scale out is nothing but as per the demand, allocating the resources on demand is what scaling out. But my requirement is only 7,000 users, but I have infrastructure for 20,000 users. So now that's the reason organizations are going to be in huge loss. Their investment has gone wasted uh, without the proper planning and all. So cloud is the best solution to overcome such situations. So how cloud is going to help you out is that you don't have to buy the infrastructure upfront. Instead, you grow your infrastructure whenever you need them, because these services are given by some of the other vendor. So in 2016, you have it there, 1,000 users, fine. In next day, you expected at some 4,000 users, fine. But later on, that 4,000 has come to 3,000. You remove one server which is not in your, which is not being used. That means you have the ability to scalable. That means you have the ability to increase your infrastructure on demand, and as well it is giving us the elasticity. So elasticity means contraction of your infrastructure when there is no demand, and you are only paying for the 3,000 users, and you don't have to worry about the additional servers. When your requirement goes now 5,000, this cloud has the ability to provision additional servers when it is required. So that is what is elasticity. So scalability is something where we have the ability to increase the infrastructure, and elasticity is we will be able to expand and contrast on demands and off demands. So now the organizations can sit without having to worry about the investment cost on infrastructure, because this infrastructure is given by our AWS infrastructure, and we are only paying for what we are being used. So this is what a normal understanding of cloud, guys. The people, why people are going to cloud is that for acquiring a scalability, elasticity, and highly available and fault tolerance environment without having to invest money in the infrastructure to manage that. That's the reason people are migrating most of their data centers or most of the infrastructure from on-premise to AWS cloud to get rid of the management cost and operational burdens in their organizations.
Yeah,
So
Shiva,
this is,
small doubt.
yeah.
My doubt is like, what is the difference between scalability and elasticity? Both way we are adding more nodes, right?
Yes. So uh, good question. Now, when we are talking about scalability, look here, look in this example, on-premise. I'm talking about on-premise. When I say on-premise, I have to manage this infrastructure. So with on-premise, you are able to scale up from 1,000 users to some 20,000 users without having to worry. And for managing 20,000 users, say suppose you require some 1,000 servers or 100 servers, or say 1,000 servers, and for managing 1,000 users you require only some 100 servers. So you are able to scale up your infrastructure from 100 to 1,000 without having to think of it.
Yeah.
But now my demand is not 20,000 users, my demand is only 7,000 users. So now in this case, if I am managing my own infrastructure, will I be able to get rid of the additional servers which are not being used?
Okay.
Because I have bought them, I have invested money in them, I bought them, now they are my own infrastructure now. So
Yeah.
I will not be able to dismantle them. So these ups and downs you will be able to accommodate with the concept called elasticity.
Okay.
Clear?
Means whenever our data got filled in the existing servers, then only we can add new nodes to the cluster. That is called elasticity. Without knowing the means how much I need to
Yes.
store, that is called scalability. It's just a number. Scalability
So
like
on demand, scalability is something like on demand you are able to increase the infrastructure.
yeah.
When the demand has decreased, let me give an other example. Say suppose I am running a site like Amazon. Let's talk an example of Amazon.com. So Amazon.com is what? Amazon.com is a web server, right? Which has all the products where I log in and every people will log in and they buy the products in it. So on an average, Amazon says that my users on average on a daily basis, I have around 1,000 users who logs into my website. So to accommodate these 1,000 users in the backend, say suppose they manage some 3 servers.
Okay.
But Amazon has put an offer saying that at Thanksgiving Day, on December 25th, they are putting some offer saying that all the services and they are giving some around 80% of the discount on all the products. Right?
Yeah.
That is on December 25th. So Amazon expects that then people are going to be some 10,000 users who will be logging into my website. So in this case, you tell me what is going to happen now?
Means, if we use only 3 servers, website gonna hang up. So we need to use more number of servers to manage the traffic.
True. That means to manage this 10,000 users, say suppose I am provisioning 30 servers in the backend. Okay. Some 30 servers I am provisioning backend. But after December 25th, my offer has expired.
Yeah.
Okay, that means
Yeah.
that's about scalability. So increasing from 3 servers to 30 servers, I can call it as a scalability. But after December 25th, my workload will come to a normal workload, that is only on an average I will be getting only 1,000 users in my website. So in that case, why will I have to put additional 20 servers or 27 servers in my infrastructure? I will remove them all and I'll come back to my normal infrastructure, that is 3 web servers.
Okay.
That means on demand from 1,000 to 10,000, I am able to scale up my web server infrastructure to accommodate 10,000 users. And once the demand has been decreased, I will come back to my normal situation, that is 1,000 users, and I will be managing only 3 servers. This is what elasticity is.
Okay.
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 And
Okay.
this kind of environments you will be able to do it with the help of a cloud. You have the ability of expanding your infrastructure and contrasting your infrastructure on demand, and you're only paying for the resources that you're being used.
Okay. Got it. Got it. Thank you, Shiva. Thank you so much.
Okay. Okay. So that's it, guys. So this was a basic and very high level understanding of what is cloud. So we'll be talking more about these concepts in the coming sessions. So now let me show you the course content that we'll be covering in this. So guys, our main purpose of this course is to cover Amazon Solution Architect Associate. So basically the Solution Architect Associate certifications are done by a guy who has around 1 to 1.5 years of experience on your AWS, hands-on experience on your AWS. It's not only hands-on experience, they should be able to design the infrastructure based on the client requirements. So now this course will give you that kind of insight where you have the complete understanding of the AWS services, as well as you will be in a stage of designing the infrastructure for the client based on his requirements. So as a part of the course, we'll be talking about the AWS concepts and the terminology. So guys, terminology plays a very major role in our Solution Architect Associate, because Amazon has designed almost every service they are giving us on top of the cloud. But we need to know what service is used at what point of time and what is the name of the service. So in the first sessions, we'll be talking about the concepts of AWS, where we'll be talking about the architecture, of the AWS, how they have designed their data centers and all. And once we are done with this, we'll be talking about user administration. We call it IAM, Identity and Access Management, where we talk about how to create a users and how can we allow them permissions, how can we federate a users, how we are be able to do certain access, limited access to the users is all we'll be seeing in a IAM. And S3, So S3 is like a storage service, just like the Dropbox or iCloud. Amazon is also giving us a storage service called S3. We'll be talking about S3, how to put our data, how to get our data, how we'll be able to secure them with our encryptions and all. It has inbuilt features such as versioning, lifecycle policies, hosting a website. So hands-on also will be given to you in this session. EC2, Elastic Compute Cloud. So Amazon has started his cloud journey with this service called EC2. It is something like IaaS, infrastructure as a service. So we'll be talking about infrastructure as service. I'll need to understand what exactly infrastructure as service is, what are the type of clouds, and what are the services that the clouds are giving, the deployment models, and everything will be talked in the next classes. And we'll be talking about RDS. RDS is something like a relational database services. So provisioning your databases on demand and making them highly available, taking the snapshots and restoring from the snapshots of a database. We'll be talking in RDS. VPC, virtual private cloud, where we define our own kind of network, own private network in our AWS. We will be having, we'll be creating own private subnet, public subnet. We'll be talking about routing tables. We'll be talking about firewalls, security groups, NAT instances, and how to connect our on-premise data centers with AWS. We are going to cover in a VPC. And after that, we will be building a completely highly available and fault-tolerant environment by using the services of AWS such as AMI, Amazon Machine Images, and building our load balancer, elastic load balancers, and using a highly scalable auto-scaling feature. So guys, till the module 7, I can say that if you are looking for the certifications, you will be covering some 60% of the content. So till module 7, we have a complete hands-on labs, and you will be understanding the complete architecture of the environment. So these 7 services are the hardcore services of AWS, which every client or every organization is going to rely on. The remaining services which we are going to talk will make the job of a admin simple. That is enabling a direct connect. So direct connect is a service which will allow us to connect our on-premise data center to AWS. Kinesis is an analytical tool. We'll be talking about how the Kinesis is used. A CloudFront is a content delivery network tool. Route 53 is a DNS service. Route 53 is a DNS service where it does all the routing policies and all. SNS, notification services, queue services, workflow services, Elastic MapReduce, and Beanstalk and CloudFormation. So these are PaaS services, which are nothing but platform as a service. We'll be taking how the Beanstalk being used, how to create an environment as a developer. So how can we create a development kind of infrastructure and queue them? This is all we are going to talk in a CloudFormation and Beanstalk. And then we'll be talking about CLI. I will be giving you a complete understanding of how we'll be able to use a common interfaces by launching a EC2 instance and S3. And then this part, so till here, after the 7th module to the 17th module, which will make up to some 30% of your exam. And remaining 10% is going to be your troubleshooting part and understanding the implementation design best practices. How well we'll be able to design a cloud infrastructure by using AWS services. What is the best practices? How do you monitor them? How do you protect your data? What are the mechanisms that AWS is giving us in order to protect our data is what we are going to talk. And talking about disaster recovery, we'll be talking about how disaster recovery happens, what is an RTO, what is an RPO, how we'll be able to do it across regions is what we're going to talk in our data centers. And the troubleshooting part, so which is very key part, and understanding the basic troubleshooting. So since we are going to put up around good experience, working experience on AWS, this session will give you a complete understanding of how the troubleshooting will be done in your AWS infrastructure. So guys, altogether, this course is completely designed for you to get enabled for Solution Architect Associate, and we'll be covering all the modules, and I can assure you that once we are done with this course, you will be able to clear your certification easily. So this I'll be sharing you guys, and please go through it, and if any questions you can get back to me.
Okay.
Any questions?
Clear, Shiva. Clear. Very clear.
Okay. So thank you guys, and I'll be sharing you the content.
Okay.
In any questions you can get back to me.
Okay. Thank you.
Thank you.